In this video, I'm going to explain the mesh analysis method by using the help of calci, and by the end of this video, you will be able to solve mesh analysis problems and also be able to use the calci for finding the mesh current. Let's consider this example, and by using the following steps, we will be able to solve the mesh analysis problems. Step 1. Identify all the meshes in the network. Now, meshes are the independent loops that are present in the network. For example, in this example problem, we have the meshes as these independent loops. Now, in the step 2, we have to select mesh currents, and these mesh currents are usually assumed to be in clockwise direction. So we will assign the currents in clockwise direction. And step 3 is to put the signs as the Kirchhoff's laws. And step 4 is to use the KVL, and I will be explaining, don't worry. Step 5 is to solve the simultaneous equations. So now let's begin the problem. Now we have these meshes. We have two number of meshes, that is 2 independent loops. So we'll be writing the step 1, which is identify the meshes. That is number of meshes equal to 2. And now here's the mesh 1 and this is the mesh 2. We will be calculating the mesh currents of these two meshes. We have to calculate the mesh currents of each meshes. Now we will be assigning the sign convention for each mesh. Now let's consider the mesh 1. We have this voltage. The long line is positive and the other one is negative. Now we have to assign these alternative symbols for resistance. Plus and then minus. And we don't have anything else again. So now by clockwise direction, we will be writing 5 volts B equal to IR. So I is here I1 and R is nothing but 2 ohms. So it will be 2. So we will write 2. Next resistance is 2 ohms. It is coming from positive to negative, so it will be negative, and the current is here. I2 is also flowing here. Be careful about this. So in the mesh 1 we have I1 current, but in the mesh 2 it is connected with I2 as well. So the I2 current is flowing upwards. So in such cases we will be writing I1 minus I2 here, because I1 is the mesh we are solving at present and it will be dominated as well. So I1 minus I2. I1 will be positive inside the brackets and I2 will be negative. So this is how we have to write for solving the mesh analysis problems. So the direction of I2 is opposite to the direction of I1 current. So that is the reason why we subtract it in this way. Now it is equal to 0, and on further solving we will get an equation, and that equation is called the simultaneous equation of mesh 1, and we will be solving the mesh 2 current as well in the same way. So this is the mesh 1 equation. So for mesh 2 we will be doing the same thing, but carefully observe one thing, that is the 2 ohms resistance. So here it is connected with mesh 1 as well. So the mesh 1 circuit we had positive above and negative below. So if you see this complete circuit, if I write it again for you for better understanding, the longer line we had positive and the shorter one negative, and this positive is going positively and then again negative, and then alternate signs for resistances, and the opposite signs for positive is negative and negative is positive for mesh 2. Similarly, alternate symbols for the resistances and the battery as well. So we have to redraw it in mesh 2 separately. So we have separately drawn the mesh 1 and mesh 2. So you can see the mesh 2 currents. I'm assigning the values like this. So this is the way you have to write the symbols for the meshes. And then the same procedure as we have done in the mesh 1. Now by applying the KVL rule for the mesh 2, we will be getting, so first we have to check the 2 ohms resistance. So the I2 current is flowing clockwise from positive to negative of the resistance 2. So it is minus 2, voltage drop is taken, and I2 is positive because we are solving mesh 2, which is I2 current. So I2 minus I1, and then it goes from positive to negative. So voltage drop again, minus 4 I2. Next we have minus 6 I2. No other currents are flowing beside the 6 ohms. So next plus 10 10 volts. So in the mesh 2, we have taken I2 as positive value inside the brackets, since as you can see that I1 current is flowing downwards and the I2 is flowing upwards. Both have a difference in between them, and that is I2 minus I1. As we are solving it for mesh 2, the I2 current is in the mesh 2, so I2 will be positive. And further solving, we'll get an equation, and that equation is the simultaneous equation of mesh 2. This is the equation of mesh 2, and the mesh 1's and mesh 2's equations are ready to be substituted in the calci. So here we go, and these are the simultaneous equations, so we'll be selecting it in the calci. Now turn on the calci and select mode, and in that mode go below. So as you can see, I'm zooming it, so we have several options. So go down below and you can find the A, which has equation and function. Select it. How can you select A? So if you observe the calci, we have A here. Use the alpha button for this thing. So I'm gonna press the two keys together, so we'll get this thing. So 1 is for the simultaneous equation. Since we got the simultaneous equation, so we have to solve it in this way. And then we have two unknowns, that is I1 and I2, so we have to enter 2 in this calci. And now just simply substituting the values that we got, we get the equations. Now the equations we got is 4I1, so 4 I'm gonna write, and then minus 2I2, so minus 2, and the constant is 5, so 5. Next equations is 2I1, so 2x, and minus 12I2, so here you can see minus 12, so I'll be entering minus 12. So according to your calci, you can check it wherever the options are possible. Next minus 10, so enter equal to, then we get x equal to 25. So here we have in fractions, so this is S to D is nothing but standard to division decimal, so we get 1.81. This is the answer for the mesh current I1, that is 1.81 ampere. And for I2, just press equal to button, and then we convert it from standard division to decimal, so that is 1.13. so I2 is nothing but 1.13 amperes. So that's simple. So instead of using the Cramer's rule, you can use the calci in this way for solving the mesh currents, or even for the node analysis we will be using the calci as well. So this is the way we have to solve by using the calci, and I hope you have got to know how to use the calci for calculating mesh currents. Thanks for watching.